Hello students, in this video we are going to study the reader-writers problem. So this is the second classical problem of a synchronization. Even for classical problem of a synchronization, we may call it as a classical IPC problem, that is interprocess communication problem. So this is the second problem. So first problem is bounded buffer problem that we have studied in the last video. So in this video we are going to study the reader-writer problem. So what is reader and writer? Reader and writer are the two processes. Okay. So the reader-writer problem is are nothing but the two processes you can see. So what these processes are going to do? So it relates to a data set or a file where the certain data or where certain data has been shared in between the processes. Okay, so certain data or a certain file has been shared between the two processes or more than two processes, you can say. Among these various processes, the processes may be a reader or it may be a writer. So what reader process is going to do? A reader process is going to read only the content of a file, or it only reads the information or a data, you can so they cannot update or they cannot edit the things. Clear? So now the writers are the processes, they can perform both read and write operation, means even they can read and even they can update the contents of a file. Clear? So now the reader writer problem, why we need to use this reader writer problem? The reader writer problem is used for managing the synchronization among the various processes, so that there should not be a inconsistency. Okay, so what is the read writer problem here? So what is the reader writer problem here? So the problem is here, if two or more than processes want to access the file at the same time, if two or more than two readers, the read processes, the readers want to access the file at the same time, then there will be no problem. Clear? So if two or more than two readers are nothing but the process. Clear? So if two or more than two readers wants to access the file at the same time, then there will be no problem. Okay, so in other situations, like when two writers wants to access the file or want to update the file at the same time, then there will be a problem. Or if one reader and one writer wants to access the file at the same time, then there will be a problem. So how we are going to remember these three, when there will be a problem or when there will be a no problem? So you have to remember this table. Okay, so let us understand the possibility of reading and writing with the help of a table. So there are four possible cases. So we have taken here the two processes, as you know, reader and writer. So when two processes, that is when writer wants to write the file at the same time, same file, then there will be a the writers are not allowed. Clear? Writing, the process 1 also wants to write and even process 2 also wants to write, so then not allowed it is. Okay, so similarly even the process 1 also wants to read at the same time, and even at the same time the process 2 also wants to write, then we cannot share that file here. Okay, there is no permission to access that file and even to write or update. Clear? So when the process 1 wants to write something on the shared file, and at the same time the process 2 wants to read the content of a file, then there is also a permission is not going to be granted. So only in case when the two processes or more than two processes can read the files at the same time, then only it is allowed. Clear? So write is not allowed, reading writing is not allowed, writing reading is not allowed, and only a reading is allowed. Means only the more than two processes or more than two processes can access the file at the same time. So in this case only the permission is going to be granted. Clear? So now what is the problem here? You got it. So what is the solution for this reader writer problem? So hence we need to design a code in a such a way that if one reader is reading the content of a shared file, then no writer is going to be allowed to update at the same time according to this table now. So similarly, if one writer is writing, then no reader is allowed to read a file at that same time. Clear? So similarly, if one writer is updating the contents of a shared file, then other writer or the other process should not be allowed to update the file at the same time. Clear? So however, as you know here, the multiple readers can read the file at the same time. Clear? So for this we need to write the pseudo code, or you may call it as a program here. So as you can see here, so this is the code for a reader process. Okay. So the solution of readers and writers can be implemented. So before explaining the code, you should know here, as I have explained the binary semaphores, I hope you have watched that video. So the solution of readers and writers can be implemented. We can write here, or we can find here the solution for this problem. So how you are going to implement this? How you are going to find the solution? By implementing the binary semaphores. Remember, we are using here in code we are using the binary semaphores. Means there is a binary semaphores means it takes only either true or false, that is 0 or 1. Clear? So we use here the two binary semaphores. We are using in this code two semaphores. Binary semaphores we are using, but two binary semaphores we are using, that is mutex and the db. Okay, so in code you might be seeing here a mutex and a db. Okay, so now in the code, before explaining the code, so whatever I have declared and initialized the variables value, you should know here. So in this code of a reader process, the mutex and the db are the two binary semaphores, so that are having here the initial value of 1. So as you can see here, a semaphore mutex is 1 and semaphore db is equals to 1. So before that, one more variable we have initialized, that is rc. So rc in short I have written. So rc is nothing but a read count. So what is a read count here? A read count is a variable. It denotes the number of readers accessing the file at the same time or concurrently. The read count or the RC is a variable. It denotes the number of readers accessing the file. Okay. So now so as you can see here, the both mutex and the db are the binary semaphores. The both are common in the reader and writer process. So in this on this slide you can see here only a reader process, but even in even in writer process code we have used the same variables, okay, or same binary semaphores. Clear? So the semaphore mutex, it ensures what is the use of a mutex variable or the binary semaphore? It is used to ensure the mutual exclusion. So why we have to ensure here the mutual exclusion? So we have discussed, or we know here what do you mean by mutual exclusion. So what is mutual exclusion here? The mutual exclusion is nothing but when more than two processes wants to access the certain code or the certain shared content or the shared data, we have to concurrently, they both are allowed to access them. Okay, so hence we have to ensure here the mutual exclusion. So that's why we have used here the mutex variable. So similarly, what is the use of a semaphore, a db? So db, it handles the a writing mechanism means for in writer process. Okay, so now I am going to explain the code of a reader process. So already I have initialized here the variables RC, mutex and DB. So RC is initialized to 0. Why? Because initially the no processes are not reading the content of a shared data. Clear? So now the while true, so this is here the while reader is a function name and it is not returning, so hence we have written while. So while true means it will always be true. So wait and signals, so as you might be knowing, or you can as I have explained here the while studying the semaphores works on only two operations, that is wait and signal. So in wait what we are doing, in wait we are decreasing the value of a semaphore, and similarly in signal we are increasing the value of a semaphore. So you need to understand the first semaphore how it is going to work, then only we are going to understand the code of this reader process. Clear? So now wait mutex. So what is a wait mutex here? In this mutex is nothing but initialized value as a 1. So wait mutex means we have to decrease the value of a semaphore by 1. We are decreasing the value by 1, that is minus minus. So the mutex value will become, initially it was 1 and now if I wait mutex means I have to decrease the value of that, so hence it will become a 0. Okay. So initially it was 1 and later it has become a 0 when I call the wait operation. Clear? So now RC is equals to RC plus 1 means we are incrementing the value of a read count. There are 4 possibilities or the 4 cases I told, right, in the last table or in last slide. So 4 possible cases we have to trace here. So first, suppose the reader wants to access the file now. So one reader has entered now. So wait mutex means we have decreased the value of mutex, so it has become a 0. Okay, so now we have to increment the value of RC, because according to this code RC is equals to RC plus 1. So now initially the RC value was 0, so now it will become 1. Okay. So if RC is equals to 1, so now RC value is now has become 1. So now 1 is equals to 1. So if it is true, we are going to perform the signal operation. So signal operation, what it does? The signal operation, we are incrementing the value of semaphore. So which semaphore we are incrementing? DB. Okay, there are 2 semaphores, as already I told. Now we are incrementing the value of a signal. So signal DB. Okay, so now DB has become now what? 2. So now if it is true, now we are going to read the shared data file. Okay, then further code is not going to be executed. So now that process or the reader process is reading the contents of a shared data file, as I have written in a comment line. So now at the same time one more reader wants to access the file now. Okay, so now the one more reader, so you need to remember here the value of a previous iteration, that is RC has become 1, mutex has become 0 and DB value has become a 2. Okay, because we are incrementing the value in a signal operation. So now while will be true, wait mutex. So wait mutex was initially 0, but reader R1 in R1 it has become a 0. So wait mutex means we cannot mutex means we are decreasing the value of what? A mutex. Clear? So now RC is equals to RC plus 1. So RC is equals to RC now it is going to become 2. So now RC value has become now 2. So 2 is not equals to 1. So in that case we are not going to perform the signal DB. Okay. If it is only true, then only we are incrementing the value of db. Okay, if not, so we are reading the shared data file. Clear? So the solution of, so as I told here, the code in code we have initialized, and what is the use of those initialized variables we know here. In the above code of reader, mutex and db are the semaphores that we know. So the read count variable, it denotes what it denotes. It denotes the number of readers, how many number of readers are accessing the file at the same time. Okay, so whenever the variable value read count is going to become 1, so in that case we are going to perform the wait operation. Okay, so it is going to decrement the value by 1. So this means that the writer is not going to be allowed to access the file. Okay, so on completion of the read operation, the read count is going to be reduced, or it is going to be decremented by 1. So as you can see in a code. Okay, so when read count becomes 0, the signal operation which is used to that is the signal db, which is used to permit a writer to access the file. Okay, so now the writer process. So code for writer process is only this much. So we have used here the writer as a function name, and it is not returning anything, so hence void, or you may keep empty. So while true means it will always be true. Then wait db. So wait db is what now? Wait db is, we are decreasing the value of a db semaphore, or a binary semaphore db. So now if it is true, we are writing into the file. Okay, so after that we are incrementing the value of our binary semaphore, that is db. So if a writer wants to access the file, so in that case we have to wait operation is going to be performed on the semaphore db. So what it does, which is going to be, it decrements db, because according to the wait operation we are going to decrementing the value of a semaphore, that is db, and no other writer can access the file at the same time. So on completion of that particular writing job, we have to increment the value of a db by calling the function signal. Okay, so hence the signal operation is performed on the db. Clear? So this is how the reader writer processes. So this is what the solution of a reader writer problem. So this is also very important for your exam purpose. So watch the video, and if you are having any doubts, you can clear your doubts, okay, by calling or by messaging. Okay, thank you.